We've talked in class that the centroid formula in the coordinate plane for finding the ordered pair of the centroid is simply taking x1 plus x2 plus x3 and dividing by 3, and then y1 plus y2 plus y3 and dividing by 3. And that gives you the ordered pair for, in this case, that point right there, your centroid. And we've discussed this. I don't like giving you guys formulas that I just tell you they work and take my word for it. I want you to see where these come from. Okay, now we have enough math background to be able to do this. It's just kind of an elongated process, and some of the algebra can be pretty tedious. So I'm actually going to do a lot of the preliminary work, but then I'll use a program to kind of do the algebra for us and show us that this formula is true and why it works. Okay, so we know that if we're trying to find the intersection point of two lines, if we know the equation of those two lines, we should be able to set up a system of equations that solves for the intersection point. Okay, so the centroid is the intersection of two medians. So we need to kind of deal with these medians. So the first thing I want to do is look at this red median. And if I focus on this red median, there's a midpoint right there. And we know algebraically we should be able to find the ordered pair for that midpoint. The ordered pair for that midpoint is the average of the x values for the endpoint, so a plus e over 2, and then the average of the y's, so b plus f over 2. So there is the ordered pair for that red line. Okay. We also then have, and I'm going to call that red line just line L, so I can talk about it a little bit easier. We also have then this blue line, which we're going to find the midpoint down here. And that blue line's midpoint is going to be add the x values of its endpoints, so C and E, add those together, divide by 2, and then D plus F, my y values, add together, divide by 2. So there's that ordered pair. Now with that information, we actually have enough of an ability or enough information to allow us to find the equations of those two lines. So let's first kind of talk about what we're going to use. We're going to always, when we come up with the equation for a line, we're always using y minus y1 equals m times x minus x1. Okay, so I'm going to come up with the equation of this line L, and actually I'm going to call the blue one line M. So right now, coming up with the equation for line L, I need two things from line L. I need the slope, and I need an x1, y1. All right. I think the easiest thing here to do for this red line to find x1, y1, I've got choices. I can use that point there, or I can use that point there. Hopefully you would agree with me that C comma D looks like a better point to choose. So I'm gonna let x1 and y1 be C comma D. Okay. Now slope, or M in this case, is going to be a little bit more difficult to figure out. But we're going to have to use our slope formula. So slope formula is the fact that y2 minus y1 over x2 minus x1 will provide the slope. Now the only thing is, this is x2, this is y2, this is x1, this is y1. So now we're going to have to go and rewrite b plus f over 2, that's y2, minus y1, which is d, all over then x2 minus x1, x1 being c. So there's our slope. Okay, now it's kind of ugly, so what we're going to do is we're going to add two fractions here, so I need a common denominator, so it's going to be 2 over 2. So 2 over 2d is still just d, but that gives me b plus f minus 2d all over 2. And for the same reason down here, I'm going to make this a 2c over 2. So the bottom becomes a plus e minus 2c all over 2. Now, finding the slope here, we've got b plus f minus 2d over 2. Okay, so it's a fraction, and then we're dividing by that fraction. So we multiply by the reciprocal. Give me 2 over a plus e minus 2c. These 2's cancel out, and now I'm left with slope being equal to b plus f minus 2d all over a plus e minus 2c. Okay, so that is an equation that provides me the slope of, in this case, that red line. Okay, I'm going to show you here in a moment kind of a visual proof of what is going on here with that information. So slope is b plus f minus 2d all over a plus e minus 2c. So what happens here is that slope for the red line, if I know what these numbers here are, and I know what these numbers here and here are, if I know the ordered pairs for the vertices of the triangle, I can simply pluck those values out. Whatever this b value is, put it there. Whatever this f value is, put it there. Whatever this d value is, put it there. Same thing with a. Pluck that a out, put it here. Pluck the e out, put it here, and pluck the c out and put it right there. And if I evaluate that, that's going to be the exact same thing as the slope of that red line, no matter where a, b, and c go in the coordinate plane. So kind of give you maybe the situation here that's going on. We're trying to find, and I'm gonna use GeoGebra to do this, but show you the task that we're trying to find the slope of that line right there, and it doesn't matter where these points go. So what we've done, if we kind of think about this, I'm going to just write a generic kind of program here that provides me numerically what that quantity would be. So b is this b value. Just don't worry about what I'm typing in down here, but this b value here is the y value that came from point A. So that's another way of just saying b. Okay, but GeoGebra have to use the y value of a. Plus then, okay, now f is the y value of c, so I'm going to say the y value of point C, minus then 2 times d, which is d is the y value of b. So that's the numerator. So it went away. Write again real quick. Y value of a plus the y value of c minus then 2 times the y value of b. All right. So just kind of verify what we've done there. We've taken b, which is this number right here, plus f, which is this number right here, minus 2 times d, which is this number right here. So obviously using different variables and stuff like that, but it is exactly the same algebraically that this numerator is. Now we do the same thing for the denominator. So a is now it's the x value of point A. I'm going to add to that so e is the x value of point C, and then minus 2 times c, and c is the x value of b. So 2 times the x value of b. And make sure we got our parentheses here all kind of situated. And I should be able to hit enter. And all the GeoGebra is going to do, I hit enter and didn't do anything, but you see over here in the algebra that it's giving me this kind of 1/11th value. Okay. So then when that 1/11th should be the same thing as this slope right there. Okay. 0.09. Well, if you take 1 divided by 11, it does give you that 0.09. Okay. But what is nice about this is that when I move these points around in because this 1/11th right now is provided that we are using those ordered pairs. Okay, so knowing those ordered pairs, it gives me a formula to find the slope of this red line. Okay, which is, it's kind of hard actually, because I don't know this point, I don't know this coordinate pair based off just the blue points. I'd have to do a little work there, but that formula gives me the slope of that red line. So no matter where these points go, you see now that red line is 0.27, and this is the algebra there that's showing that's 0.27. All right, so this is kind of a nice thing to have, because now you know slope of this line based off of where these points exist and nothing else. Okay, which is maybe kind of weird, kind of odd, because normally if I want to find the slope of this line, then I'm going to use the endpoints of that line. Well, now finding the slope of that line, I can simply use the vertices of the triangle to do that. So that's nice. Now, what would we do with that m value? Well, we're going to plug that into this with that x1 and y1. So I end up with y minus y1, y1's d, is equal to m times x. So m, let's write it as, that's the b plus f minus 2d all over a plus e minus 2c, and then times x minus x1. Well, x1 is this c. So then what happens is that we would solve this for y, so we get the opposite, add d to both sides, so I get b plus f minus 2d over a plus e minus 2c, x minus c plus d. All right, so what this provides me, this is a formula for an equation of this red line, no matter where these vertices go. Okay, so let me see if we can do this in GeoGebra to kind of prove this. We've got our slope. So I'm going to write y equals, I'm going to go m. Okay, now m is my slope, so I'm going to type in this letter right here, because that's the equation we just talked about, so I'm going to use e. And then times, let me see actually, e, so hit that button. Oh. So I'm going to go y equals, I think it's going to reference that, yeah, it is reference that e. Then times x, I'll just let x be x, minus then, now, minus c, but c was the x coordinate of b, so it's going to be minus the x coordinate of b. Okay, so that's this part here, so we're going to put that slope x minus xb, so that's good, and then we're going to go plus d. This d here is the y coordinate of point b, so I say y of b. And when I hit enter, that should provide me a line right over the top of line L in GeoGebra. So when I type that in, you see that that is that black line. That's right over the top of the red one. Now what's nice about this is that equation adjusts and changes no matter where I put my vertices. Okay, so this rule here that I've just created, this rule here, is a rule that provides me that median's equation based solely off of knowing what A, B, C, D, and E, F are. And I just plug those things in to that expression there, or that side of the equation, and it will produce that equation right there, which is what I'm interested in. That's the equation, the median. Okay, so hopefully that kind of makes sense on what we're doing there. But the reason we're doing this, the reason I need that, is because we're then going to do the exact same thing for the blue one. Okay, I'm going to save a little bit of time of doing that, but when I deal with the blue one, Okay, let me write the red one up here for a moment. The red one was, let's see here, y equals b plus f minus 2d, and then a plus e minus 2c, and then x minus c, and then plus my d. Okay, so that was the equation of the red line. Now let's find the equation of the blue line. Okay, you would go through the exact same procedure we just did with slope, and then choosing x1 and y1, and when you do that, you're going to get y equals d plus f minus 2b all over c plus e minus 2a times x minus a, that's my x minus x1, and then add b to both sides. So that's finding this equation, this blue line. We're finding my slope. That would be the slope of the blue line, and this is the x1, y1 that I would have chosen for that. So here's the idea. Here's what we're doing. Whenever algebraically we want to find out where these two lines intersect, we set up a system of equations. Well, right now, we have the equation of the red line and the blue line solved for y, so we know those when these two lines intersect, those y values are the same. So logically, just like anything else we've done so far this year, when we deal with this type of thing, the right-hand side should be equal as well. So I'm going to take b plus f minus 2d over a plus e minus 2c times x minus c plus d. That should equal the blue one, which is d plus f minus 2b, or c plus e, c plus e minus 2a, times x minus a plus b. Now I've done, there's some more algebra that's involved here to kind of, basically we set up our equation. And this is just like if I had the equation, let's say that the blue one was y equals, I don't know, 2x plus 5, and the red one was maybe 1/5 x, I don't know, plus 4. Okay, we would set these two things equal to each other, solve for x. That's what we've done here. Okay, now we got to solve for x. So the algebra would incorporate us kind of having to distribute this x to that stuff, distribute the negative c to that stuff, combine with that d, so I have the common denominator type stuff. And eventually what that's going to lead me to is the left-hand side is going to look like this. The numerator is going to be dA minus bc plus bx minus fc plus de minus 2dx's plus fx, all over a common denominator of a plus e minus 2c. The right-hand side is going to look like this. It's going to be dA plus fa minus bc minus be plus 2bx minus dx minus fx, all over the common denominator of negative c minus e plus 2a. Okay, so we end up getting a proportion. Now, the way we would solve this, I'm going to use some tools here in a moment, but the way you solve the proportion is you cross multiply. So I multiply those two things, and I multiply those two things. Okay, and I would get now basically an equation without any ratios. But when I do that, multiplying a trinomial times 1, 2, 3, 4, 5, 6, 7 terms, give me 21 things on the left-hand side of my equation, and this would give me 21 things on the right-hand side of my equation. I have a lot of things that I can combine and eventually factor. Okay, so there's a lot of work that is involved beyond this point that maybe we're not all that skilled at right now. We don't have those. It is simply just multiplying and adding and combining like terms, and then doing a little bit of factoring. But to save ourselves a little bit of time, I'm going to use this program. It's called Maple. Okay, so what happens here is that I can simply take, I'm just going to delete some of the stuff that I've already put in here. I can take the information, okay, from my slopes, Okay, so I'm going to say the slope of, you know, I have, so b plus f was the, so b plus f, slope of the red line. So I'm just going to say red here. Okay, so slope of the red line, I type that in and hit enter. Okay, now what this is going to allow me to do is I'm going to be able to go and before I can I do anything further, I'm actually going to type this into a different worksheet because I'm afraid that what I've done there is going to kind of mess things up and not prove my point here a little bit. Okay, so slope of the red line is that. So now I want to find the equation of the red line. So what this allows me to do is just simply says, you know, type in y minus y1. Well, we said y1 for the red line, we used d. So I'm going to go y minus d is equal then to, now I would type in my slope, but the way this works is I can just type in, I've named slope up here. So it's going to, whenever it says slope underscore red, it's going to reference this thing here. And we'll multiply that then by x minus x1. Well, we let x1 be c. So then I'm going to hit enter, and that becomes the equation that I'm looking for, but I want to add d to both sides. So basically I tell this thing to solve the last equation for y, and it will move that d to the other side for me, and that then ends up being the, you know, you see is dA minus BC kind of comment. That is this left-hand side here. Okay. Then I'm able to do the exact same thing with the blue line. So find the slope of the blue line. Find the slope of the blue line. Then I'm going to go y minus. Now with the blue line, we let y1 be b, so we go y minus b is equal to the slope of blue line times x minus x1, which was a in this case. So I get that. Okay. I'll ask it to solve the last expression for y, and it gives me that. And that is then the equation of, essentially it's the right-hand side of the equation for the blue line. So that's the blue line, that's the red line. Okay. Well, what we're trying to do then is we want this thing to figure out what the intersection of those two lines are. So we should be able to say solve. I'm just going to cut and paste this. So I'll take that expression. So this is that's the red line. We set it equal to the blue line, and I can tell this thing to solve for the variable x. Well, if I do that, hit enter, we see here that it solved for the variable x, and it gave me that a over 3 plus c over 3 plus e over 3. Well, doing a little bit of work with that, which isn't hard work, since it's a common denominator, we've got a plus c plus e all over 3. Well, if I look at a, c, and e, back to our original picture, a, c, and e are the x-coordinates of our 3 vertices. So we're seeing that the x-coordinate of the centroid, that point right there, is simply the average of the x-coordinates of the vertices. It is that right there. Instead of calling it a, c, and e, we call it x1, x2, and x3, but it doesn't matter the variables you use. So that's nice. Okay. The next thing we would do in a system of equations is once we have our x value, we're going to take that x value and plug it back in to our equation, okay, that involved y, and see if we get the same, if we get the result for the y value. Okay, so the ordered pair, the coordinate of that ordered pair. So in doing this, it's just going to be a little bit easier. I'm just going to call this up here equation 1, and that was y equal, actually, let me do it this way. Makes more sense to just call this equation 1. All right, so I'm going to evaluate this stuff again. We go through, let me solve that, we got that. Okay, I'm gonna call it this. I'm gonna call this capital X. Okay, so it shows me the capital X just the X coordinate in my centroid. Okay, so now what I should be able to do is I should be able to say we want to evaluate. Okay, which means simply take this amount and come back up into this equation up here, and everywhere I see X, put in A over 3 plus C over 3 plus E over 3. So I'm going to say evaluate equation 1, where X is equal to the X coordinate from my centroid. So this is what you would do when in a system equation. Once you know X is, you plug it back into an equation to solve for Y. If I do that, I get this number here. Okay, I'm going to ask to simplify that. And there you see that you get D over 3 plus B over 3 plus F over 3. And if we go back to our original picture, D, F, and B are the Y coordinates, and you're simply adding those together and dividing by 3. So that's kind of the justification for why this formula works, but it's all about setting up equations for lines and then seeing where those equations intersect. Okay, but it just uses arbitrary values because now it's a formula that will work regardless of where A, B, C, D, E, and F show up in my coordinate plane. Okay.